Hello, I'm going to be doing this talk from outside. It's a little noisy in my sister's house in California, so I'm doing this outside. Hopefully the sound of the air conditioner isn't making too much noise or dogs barking or geese flying over. Well, we're near Sacramento. Okay, for chapter 11, the prompt is, which do you think would work better for your content area and grade level of focus? Not or focus, of focus. The Suchman inquiry model, the WebQuest model, or the problem-based model. Why? Give an example for your content area and grade level. We're going to look through the different designs, the Suchman inquiry model, the WebQuest model, and the problem-based model. Think of these models. Which one would you be most comfortable with? Teaching your content area and the grade level, preferably the ones you're doing your unit on. And then tell me why that one would be most appropriate for you after you read. Don't just rely on what I'm saying, because I do it very short. I don't do it exactly as they say. And so read it carefully and then give an example. What topics or what problems or what topic or problem would they research? Would you prepare for them for the research? And then give an example of that from your content area. I'm looking for the examples. And of course, make sure that your references are all written correctly as usual. Okay, let's go back. Let's go into the chapter a little bit and look at my notes. Okay, chapter 11, inquiry models, teaching problem solving through discovery and questioning. First, the Suchman inquiry model. You select the problem and conduct the research. That's you, the teacher. There's probably something in the TEKS, something related to the TEKS, because there are different skills in the TEKS, and some of these skills are probably research skills, all the way from kindergarten up through high school. And so you select some kind of a problem. Now, a problem is not always math. I have problems, you have problems, the country has problems. So what is an issue or something that needs to be resolved or something they need to discover? And so you find that. And then you introduce the process and present the problem to the students. Now, you don't give them a lot of detail. You introduce the process and you present the problem that they're going to do. And of course, it's not a math problem. It's very rarely a math problem. It's usually some issue. And when the students ask you questions, you only answer yes or no. You don't go and do an elaboration, because they're supposed to come up with the questions. You say yes, yes, no, and this is part of the process that they have to go and they have to come up with good questions. And you look at the TEKS for the different grade levels, especially in science and in social studies, and students are supposed to come up with good questions, not just with answers. Not only the teachers asking questions, but the students need to ask questions as well. And the kinds of questions that you can ask, you can answer yes or no. And then the students, after you have done your research and you've come up with something that fits the curriculum and that you think they'll be able to handle, you give them some resources, and the students go and they gather data. And once they've gathered their data, they develop a hypothesis and they test it. And then they have to explain the hypothesis and state the rules associated with it, because it's not yes it worked or it didn't work. No. Why didn't it work? Yes it did work. And why? What are the rules? There's more to it than yes it did than no it didn't. How well did it? In what conditions? And so forth. And then, of course, as we usually do with this book and the topics here, it's good practice to analyze the process that you and the students have gone through to see how it works. After you analyze the process with the students, and then you evaluate. You, the teacher, did it work? Did it not work? What do I need to change for the future? That's just not giving a grade to the students, but how did it work? How are you going to improve this lesson or this project, this research for the future? More in the textbook. The WebQuest model. when I taught the minor in educational technology in the master's program, I was the only full-time professor to start out with teaching that, and there was another professor who came on, and some others who worked part-time, but I did the course where students had to come up with a web quest. So I'm familiar with the web quest and them making a web quest and analyzing web quests. And so they have a good discussion of web quests here, and you might go to the web quest site, the website, and see how they explain it, and they have a lot of models of web quests. And basically, what it is that the teacher selects a problem and conducts preliminary research. That you, the teacher, need to go and select your problem. Might be the same problem or issue, of course, not math, that you had for the Ch11 model. It might work better with the web quest, some of them. And these are ones where you're going to put links to web pages and resources. You might give them some, generally it's going to be a web search and a web analysis, data sets and so forth, that you provide them a lot of resources. Maybe some of them are productive, maybe some of them are not so productive. And they go and they can evaluate the data and see which sets of data and which web pages give them the information that they might need. So the teacher then presents the problem in the web quest unit, and the students gather data and information to solve the problem as they click on the links and they go and they find these. Now, this is a lot of work for the teacher to get everything together, but it is very quick. If you have a lot of technology in your classroom, the students have iPads and they do have internet access in the room, this is very good. This is a lot easier than going to the library. It's a lot easier than printing out a lot of Xeroxed or photocopied sheets of data sets and so forth for your students. So this might be something very popular for the future as far as a means to get to the data. Then the students need to develop and verify their solutions, very much like they do the Ch11 model. Now, when I was teaching the undergraduates, of course, we talked about inquiry learning and discovery learning. In discovery, generally, the teacher knows what the students are supposed to find out. And you have them do experiments like science experiments, and they will probably come up with the right solution, like would plants grow better in light or better in the dark? And of course, but the students are going through the motions and they're doing the experiments, and they're supposed to discover, oh yeah, that's how it works. And so in discovery, generally the teacher knows the answer ahead of time, and you're working as a teacher to set up the instruction and the inquiry or the discovery or the lesson, the student involvement, so they naturally come up with the correct solution and understanding. In inquiry, the idea is that they research, they look, and they try to find out information. They gather data. Maybe they never come up with an answer. For instance, you might have, at the college level, you might have something on maybe drug use on campus, or maybe sleep deprivation. How much sleep deprivation is there on campus? How does it affect students? And you might come up with some kind of a study, but who knows if your answer, if your result is valid or not valid. But you have done the research, you've done the questionnaires, you analyze the data. You don't have really firm or scientifically verifiable results perhaps, but you've done the research and you've done inquiry. You have inquiry when something goes wrong in the government and the Congress gets together and they ask a lot of questions and they get a lot of people to testify. Perhaps they did not come up with a solution, perhaps they're not going to change a law, but they've done their inquiry, and a lot of people are a lot more aware of the issue involved in something very complex. And so that's technically the strictest form of inquiry. is that you're not always going to come up with an answer, but you're going to understand the issue much better. So the problem-based inquiry model, again, more discovery than inquiry. All of these models appear to be more discovery than pure inquiry. Inquiry would be more like maybe a senior project or a master's thesis, where it would shed light on the information, but it would not be definitive unless more and more people replicated your study, or you're replicating the study of others. So, okay, problem-based inquiry model, which again is more in the discovery mode than the actual inquiry or the pure inquiry. You engage with the problem. They use this in business a lot. And you give a lot of data, a lot of information to students, and there's a problem. And they go through there, and there's a chart. There's a chart in the textbook on page 221, figure 11.1, the problem-based learning inquiry chart, where across the top you have question, 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 and new question. And then you have hypothesis, common knowledge sources, expert knowledge sources, observations, and problem solution. And so you go through, probably in a group, very rarely individually, but you would come up with a hypothesis, common knowledge sources, expert knowledge sources that you would research. And the common knowledge sources would be what everybody thinks they know. Then you look at also what the experts have written about. And then you come up with your observations from, you go out and you look at the data, you look at information other people have written about, and then you come up with a problem solution. And they use this a lot in medical school. I think nursing programs use this type of thing as well. Okay, here are the symptoms. What's going on here? And in business, they would have something like that. The business is failing. Here's what we have, the information we have. Why is it failing? How do we fix it? So problem-based learning is something very real world type of inquiry. Okay, so once they've explored the problem using the chart, the students will explain and share the information, and perhaps they will elaborate and take some kind of action, especially if you're doing it with some issue around the school or something that is relevant to the actual classroom. Make sure you're using TEKS if you're doing this one. Don't talk about bullying. Don't talk about drug use. Talk about something in the TEKS. This is for science. If you're a science teacher, it's for mathematics. If you are math, it's language arts. If you're language arts, it's social studies. It's a social studies issue that you might have there. But remember that this should be something very similar. Well, it should be for the content area and the grade level. Don't come up with something generic that is a societal problem. Come with something that is at your grade level and your content area. Okay, so read through the chapter. It's a good chapter. And we will, contact me if you have any questions.